Question is, in connection with the memory mapped input or output, which one of the following statements is not true? See, if we consider the statement A, the processor treats an interface register as a part of the memory system. We know that in memory mapped IO, a part of the memory is allocated to IO addresses. Means there is no separate interfacing register, memory itself acts as a IO addresses. So statement A is correct. Now if we goes to statement B, it reduces the memory space available. Yes, it is, because we are allocating the part of the memory for the IO devices. Hence, it is going to reduce the memory space available. Hence, statement B is true. If we goes to statement C, that is, the processor cannot manipulate input or output data residing in interface registers with the same instructions that are used to manipulate the memory location. Because see here, this statement is false, because here we are allocating a part of the memory space to the IO space. Means we can use the same instructions which are dealt with the memory space for the IO space too, because IO space is a part of the memory space. Hence we can use the similar instructions to manipulate the IO space as well. Hence statement C is false. If we goes to statement D, arithmetic or logical operations can be directly performed with input or output data. Yes, we can, because the IO space is part of the memory space. So we can perform directly with the IO data with the help of arithmetic and logical instructions of the microprocessor. Hence, statement C is the only statement which is false. Hence, option C is correct.
Which of the following controller is recommended if the steady state error for step input and speed of the response is criteria for the design? Okay. Now, proportional controller is for stability, whereas integral controller is for steady state error, and damping is used to improve speed of the response. Okay. If you see options, option A is only for stability, option B is for stability and steady state error, option D is for stability and speed of the response. These three options are wrong. If you see option C here, we have PID controller. That means we have stability. Okay, this is not the criteria which is given in the question. Okay, remaining two are to improve steady state error and damping. Okay, so option C is correct for this question. We have to find here fault current. Okay, let us take fault current as IF. IF is equal to VF by XF. Okay, now what does it mean? That fault voltage by impedance up to fault current, or you can say here resistance are negligible, reactance up to fault current. Okay, now what is XF here? Fault is takes place at this point. Okay, since these two are open, there is no current flow to this one. Now how these two will be appeared here? These two are in series, which is parallel to this reactance J times of 0.15. Okay, so I can write this one as J 0.2 plus J 0.15. These two are in series in parallel to J times of 0.15. Okay, this is what fault reactance XF. Now, XF is equal to, you will get it is around as J times of 0.105. Okay, total fault reactance. Now, what is fault current IF? He has given fault voltage VF as 0.97 by J times of 0.105, which is equal to minus J 9.23 per unit. Option D is correct answer. Open loop system. Open loop system, let us take it as the transfer function of open loop is, okay, zeros by poles. Okay, this is the transfer loop which is equal to G of S. Now, G of S concerns 0, Z of S and poles P of S. Okay, now open loop is stable only when P of S is equal to 0, or you can write as pole should be equal to 0. That is option B is correct. This is the condition for Nyquist criteria in open loop system. Okay, for stability point of view, option B is correct.
To find the value of the limit sin x by x if x is tending to infinity. Now, as x is tending to infinity, we know that 1 by x tends to 0. Hence, sin x by x also tends to 0. That is option C. Integral is 0 to 1 dx by x power p. Now we have to check this integral is convergent for what values of p. Now let us find the integral of this. It can be written as 0 to 1 x power minus p dx, which is nothing but x power minus p plus 1 by minus p plus 1 over the limit 0 to 1. This is nothing but 1 by 1 minus p. Now if p is equals to 1, this value is infinity, so it is not convergent. Now if p is less than 1, obviously this is a finite value, and hence the required answer is C. At matrix 2 1 3 2 into matrix A into minus 3 2 5 minus 3 is equals to identity matrix. Now we have to find this matrix A. Let us take this first matrix as some x, then the next matrix is A, and let us take the next matrix as y is equals to I. So I'll take this x to other side, that is multiplying x inverse on both sides. So it will be ay is equals to I into x inverse, which can be written as ay is equals to x inverse. Similarly, I'll take this y to other side. That means multiplying y inverse on both sides. So a is equals to x inverse into y inverse, which can be written as yx whole inverse. Now, yx is nothing but the multiplication of matrices y and x, minus 3 2, 5 minus 3 into 2 1 3 2. Let us multiply them. Minus x plus 6, it is 0. Minus 3, minus 3 plus 4, which is 1. Then 10 minus 9, which is 1. Then again 5 minus 6 is minus 1. So we know the value of yx, which is nothing but 0, 1, 1, minus 1. Now we need to find yx whole inverse. If we use the formula 1 by AD minus BC, D minus B minus C A, and find the inverse, we'll get the matrix 1, 1, 1, 0, which is nothing but option D.
The probability of a bit decoded correctly at the receiver is P. If n bits are sent, what is the probability that at most one bit is decoded incorrectly? The probability of this is, suppose x is less than k. K is at most 1, so k equals to 0 to 1 nk p power k 1 minus p power n minus k. If we solve, if it is k equals to 0, this factor goes to 1, so it is p power 1 minus p power n np 1 minus p n minus 1. Hence option D is correct. Is common properties of collection of random signals form a probabilistic model known as a random process. This is option B is correct.
The potentiometer recorders, they are classified in two types, null type and galvanometer type. Okay, now it consists of both A and B, since potentiometer recorders are two types. Okay, null type and galvanometer type. Option is C is the correct answer. Okay, he has given a true value of quality factor and measured value of quality factor. Okay, ratio of true value of quality factor, measured value of quality factor is, okay, which is equal to 1 plus distribution capacitance by tuning capacitance C. Okay, distribution capacitance is nothing but an self capacitance. Okay, now we have to find here the ratio of CD by C, okay, which is equal to Q true by Q measured minus 1. Okay, now what is this one? 245 by 244.5 minus 1. This is 2.04 into 10 power minus 3. Option A is correct answer.